Well, hello there. Welcome to the summary of the lesson on we're going to learn about three different really important points of concurrency that we're going to construct. And you can see that I've already constructed the circumcenter, which we've learned about. Okay, so these three dashed lines here are perpendicular bisectors. So I have this other tab here, and I can remind you that the circumcenter is this special point here, and it is the intersection of three perpendicular bisectors. In fact, you probably remember that it's the one point that's the same distance from the three corners of the triangle, which is why it's the center of this circle. So I could add that circle to my diagram here. I don't really need to for today's lesson, but you can see that it is the center of that circle. Let's leave that off for now. So that one's great, but I'm going to leave this up here, but then I'm going to superimpose on that this other point that I want to talk about, which is called the centroid. All right, now it's a little confusing with everything on your screen here. So actually, maybe let's hide the circumcenter for a moment. Now the centroid is it's the point of intersection of three things called medians. And a median is different than a perpendicular bisector. It's a segment that connects a midpoint to the opposite vertex. Notice how each of these black points is the middle of each side. And so we've connected this midpoint to the opposite corner. We've connected this midpoint to the opposite corner, and so on. So these are medians, and I know that they're midpoints. They're marked as such. So the question is, how do I construct a centroid? And that's why I want to reimpose this circumcenter. I want you to notice that when you do the circumcenter, when you construct these three perpendicular bisectors, do you notice that those three perpendicular bisectors intersect at the midpoint? I mean, they're a bisector, so they go right through the midpoint. And so that really is the key to constructing this centroid. We can use the perpendicular bisectors to identify the midpoints. Let me show you. So I have these perpendicular bisectors here. I'm just going to mark each side. Okay, there's that point E. That's a point of intersection, I hope. Yeah, it is. So let's do a couple others. This point here called F, and this point here called G. And I'm going to adjust these. I didn't want them to be red like that. Let's just make them black. But those are the midpoints of each of those three sides. And all I did was I used these perpendicular bisectors that I had already constructed to find the midpoints of the side. Right? So there's no extra construction to do, but we haven't actually drawn the medians yet. And so the next thing I'd like to do is actually to hide these perpendicular bisectors, because they actually end up making things a little bit difficult to look at, especially as you'll see in a minute, because I want to have all of these points on the same diagram. So look, I just connected this midpoint, point G, to the opposite vertex. I'm going to connect E to the opposite vertex, and I'll connect this midpoint F to the opposite vertex. And look at that. Those three medians all intersect at this one point here, which is called the centroid. So I am going to change it so that we can see that it's called the centroid. And I'm also going to, let's change it. Let's make it a different color. How about purple? That looks nice. All right, so now see the circumcenter and the centroid are showing up on this diagram. And, if I were to put all the lines back, it gets really confusing to look at, right? But we used these perpendicular bisectors just to identify the midpoint. And then we connected that to the opposite vertex. And that's how we found those medians that make the centroid. So I'm going to hide these segments that I just made, the medians. And I have to tell you about one more special point, and this one's a little different. Let's hide these midpoints too, E, F, and G. All right. So I have to find one other special point, and it's this unrelated one here called the orthocenter. So the orthocenter is the intersection of three altitudes. Altitudes are perpendicular lines that go through the opposite vertex. So we have to construct lines that are perpendicular to a side, but go right through the opposite side. This is actually the height of the triangle. And you can measure the height in three different ways. It really depends on what you're thinking of as the base. Like if this is the base, then this line would be the height. But if this was the base, right, over here on the side, then this line would be the height. So let's construct at least one. And there is a tutorial that you can watch, or an interactive tutorial that you can use. But I think the first thing I want to do is just extend the side. because this point C is kind of far away from AB. So doing this construction properly, I think it's just going to be easier if I extend the side, and I'm going to make a circle that's big enough to connect with that side in two places. And it might actually be easier if I just kind of make that circle attached to the line that's outside here, this extension. And then I'm going to mark the one place where that circle intersects with the side. So we see that purple point J there and this point I. Okay, C is right in the middle of the segment between J and I. So I can use overlapping circles to make a perpendicular bisector. I have to zoom out a little bit, but I can use my line tool. I think it's going to keep making these things. So let's try that and see if that works better. All right, I don't know. No, okay. So we have a nice big purple point here, K, and a purple point L. But what I did, though, if I hide all these circles, is I made a line that is perpendicular, okay, perpendicular to this side, but it goes through this this point here called C. Now, I could do the other two sides the same way. Yeah, I guess I will. I'll do the other two. I'll do one side the same way, and then I'll cheat on the last one. So now I'm working the other way, but I still want to make my circle centered at the vertex I'm aiming for. And then I'll just find that point of intersection, and then I can mark this other one over here. Okay, and then M and N, right? A is the point I'm aiming for, right? That's halfway between M and N. So I'll do overlapping circles from M to N, and then back again. And I'll connect those. And now I've got two altitudes made, right? See how I have one going through A and it makes this right angle? Let's hide these circles. And one going through C and it makes a right angle with the other side. Making altitudes is a little confusing. That wasn't what I meant to do. But once you do it, you've identified the orthocenter. And I'm just going to cheat and use the perpendicular line tool, make a line perpendicular to this side that goes through that vertex. So see there, I've identified this third point, which is called the orthocenter. It's the place where the three altitudes meet. And the orthocenter is pretty interesting and important point. Let's make it, I don't know, what should we make it? Orange? Okay, sounds good. But if we kind of, now I want to just, at the end of this video here, I want to hide all of these lines that I made to find the orthocenter, all of those altitudes. Okay, I also kind of want to hide a lot of these other points. Well, I'm not going to do all of that. But do you notice anything about these 3 points here? Even when I move them around, move the triangle around, do you notice anything about those points? If you said to yourself in your head, there's something interesting about these points, those 3 points always form a line. This is the line that you're looking for today. If you can find all 3 of these points, then you should be able to find this line, which let's make it nice and pink and big. It's called the Euler line. It's not pronounced Euler. It looks like Euler, but it's pronounced Euler. Okay, so that's the Euler line there, and ultimately that's your goal, is to figure out the 3 different points, the circumcenter, the centroid, and the orthocenter, and make them all for the triangle and find that line that connects the 3 of them. You can rewatch this video. I know I went really fast. You can also use all the tutorials, but attempt this on GeoGebra if you were not able to come to class, to find the circumcenter, the centroid, and the orthocenter all in one triangle. Good luck!